Hello and welcome to the PowerEgg YouTube channel. In this video, I will be going through the development of my first Lakehouse notebook. It will be a step-by-step process where we summarize the files in a specified Lakehouse location and save the data as a CSV file in a subfolder in that location. The idea is that this process can be automated and certain stakeholders can be updated on a regular schedule regarding the data source location situation. Thank you for watching and please subscribe for more videos. Okay, so to get started, I will walk you through a few slides just to explain what we're going to do and how the process looks to get an overview. And then I'm going to go into Microsoft Fabric and actually test the notebook code step by step and review the result and make any improvements if necessary. Okay, so we are going to build my first Lakehouse notebook, and this Lakehouse notebook is supposed to detect any data source path files. So in the Lakehouse, we have the files directory, and in that files directory, you can create also subfolders. And in that subfolder, we are going to save a CSV file with the summarized file information of that directory above it. Okay, so the process goes by the following steps. First, we need the files location of the Lakehouse and create a subfolder where we're going to save the output CSV file of our notebook from the final code. We have to choose the notebook language. In this case, it will be PySpark. And we're going to write the code and keep improving it step by step or extending it to get the desired results. These are 5 steps in total. Then we're going to run a test, of course save the CSV file and show the data frame to view the results. Do note that when Python saves the data frame to a CSV files, there will be some conversions, and the data in the data frame that we view might differ in some formats. For example, the datetime zone format compared to what we see in the CSV file later. That's why I'm also going to query the CSV file in the end and view the results so that we can compare all the differences in the data at different stages. Okay, so the first step is to create a subfolder in our Lakehouse file location, and we're going to name the subfolder data source file summaries. We have to set this up first because when we query for all the different files in the directory of the Lakehouse files, we will also experience the output giving us a summary of a directory, for example, the subfolder data source file summaries. That's why we create it first, so we can catch that mistake or that unexpected outcome that we don't desire and change the code accordingly. Okay, so let's create that subfolder. For that, I have to navigate to Microsoft Fabric, log in and create a Lakehouse and upload some files to that Lakehouse. This is the setup. So we have the Lakehouse. It is called Contoso Bronze P1, and you can see the location is Contoso Bronze. This is the name of the workspace. And in this Lakehouse, I have uploaded 3 files, 2 Parquet files, and 1 CSV file. So this is for the sales fact table. Later, we are going to have to create a union between them and process them, but we're not going to do this now. All we want now is a summary of what this file location holds. So the end result is, what I want to know is how many Parquet files or how many file types of certain sorts are in this location, and what is the total size of those files grouped by file type. So in this case, for example, it would be Parquet, 2 files and 2 times 99 megabytes and 1 CSV files with 99 megabytes. For now, the overview is okay because I don't have so many files, but the reason I'm writing this code is that I want this to be scalable. So in the future, if there are tons of files here of different formats, or if this is a kind of a data dump location for the organization, I would like to, like I said, schedule a summary and distribute it accordingly. Okay, so let's create that subfolder. We have to navigate to the file section of the Lakehouse, and we just click the 3 buttons, extensions, and create a new subfolder. Now, there is a way to also do this automatically in the notebook, but we're going to do this manually because this is just a simple step, and I'm not going to change this in the future. But for now, this is what how we're going to do it. This is the only manual step of the part of this notebook. The rest we're going to try and automate. So we click on new subfolder, and then we have to name the folder. In this case, the name will be the following: data source file summaries. Always make sure that you don't have any spaces. Maybe replace them with underscores. I'm not sure if here spaces are accepted, but generally in the Lakehouse, I found that it is a good practice to replace all the spaces in column titles, file names, source files names with underscores to avoid any problems further downstream. So let's click create. Okay, and now we can see in the location we have a folder, a subfolder, data source file summaries, and if we click on it, we shouldn't be seeing any content. Of course, this is going to change later. And yeah, so the next step is to get the file path of this location, and we are going to start the notebook at the same time. Okay, so let's start writing the notebook code. For that, we are going to need the following. First, we have to create the notebook from the Lakehouse location. So just a note there, I'm doing this from the Lakehouse location. So I'm not going to my workspace and then saying create new notebook, because then I have to do an additional step and link it to the Lakehouse. I'm going to create the notebook directly from the Lakehouse so that it is already linked. And then we're going to rename it because the default name will be notebook 1, notebook 2, etc., whatever is available. And I want to give it a reasonable name. And then we're going to define the file path location for source files. Well, it is already defined. We just have to get it. And to get it, we have to just right-click the location and find the ABFSS file. I'll show you that in a second. So back in Microsoft Fabric, I'm at the Lakehouse, and I'm still in the file section. It doesn't really matter where I am right now. In the Lakehouse, I can't click tables because there isn't anything, but that's fine. So right now I'm going to click on the menu point open notebook, and we're going to click create new notebook. All right, this will automatically link the new notebook to this Lakehouse. And as you can see, the default name will be notebook 1 at the top. This is on autosave, so it will always save while you're working on it. This is great in case your computer crashes or anything like that. That shouldn't happen. But as you can see here, we have our first 2 notes. Welcome to your notebook. So let's rename this. I'm going to give this a name where I abbreviate. So I click note NB for notebook underscore, then that it is in the bronze Lakehouse. So BLH, or I can write bronze underscore Lakehouse. And then I'll give it the name of the notebook, which is my first notebook. Okay, this way I kind of know that it is the notebook in the bronze Lakehouse, and of course the location here is already defined. Okay, so now we can click enter, I guess, and it will save it, but you can also just click anywhere behind the menu to save it. And as I said, it will autosave. Okay, so here we have the notebook. As you can see, the language here is PySpark, Python. We can change it accordingly if we want any other language. We also have the option, which is, I think, in preview. No, the web version is in preview. So we have the Open and Visual Studio Code version. The Copilot right now is not available for me because I'm in the trial license. But opening the notebook in Visual Studio Code on your desktop is also an option. It will require further setup, so you'll have to install all the extensions and set everything up, perhaps even integrate it with Git. But for now, we will just keep it simple, not do anything complicated like that. We're just going to create the notebook on the web and interact with it without Visual Studio Code. All right, so now we need the location of our files. So right now, if I click on files, I will be able to see everything here. But if I want the file path, I have to click on the extension here and just click on copy Azure Blob File System path. All right, so I copy this, and now it is in saved in my forgotten my is copied, and I can just paste it, and you can see here that what the file location path looks like, and we will have to define it in the code. So I will define it as path, and then we have to add quotation marks. And if you want so now this is a path string, so we've defined the path as the string, and if you later want to change anything dynamically in it, you have to add the function, and then inside, for example, if the lakehouse name is dynamic, you would have to define the lakehouse name and add parentheses like this. And then the lakehouse is a variable inside, a dynamic variable inside this lakehouse path. But this is not dynamic in our case. It is static and fixed. So this is the path right now that we have defined. And that's pretty much it for step one. We have the path, and we've defined the path. We have our notebook, and now we're going to start writing the code that we actually need. Right, so step two for the notebook code process is creating a list of all the files in a directory, and then converting the list to a data frame, because we cannot save the directory to a data frame. That doesn't work. And then we want to see the results. It is always, I found, really great to do this step by step in building the code, and then always viewing the results throughout the development of the code. Just a note as well, commenting or writing descriptions is really useful for myself for future reference, but also if someone else wants to contribute to the code or try to understand later what was happening. All right, so let's go through this. Here, this is step two. I will create a new cell in the notebook code and to start properly. And we are going to create a list of all the objects in the specified file location. Just a heads up, in the previous path string, I didn't put a slash at the end. We will have to add this so that the system knows that we want anything below or inside or after this path location. And then we're going to list all the files in that path. And for that, we can use the Spark utensils function, which automatically extracts certain information about files in that location. This includes the file name, the size, and other information that we can extract. So, for example, in the next step, where we define the file's dictionary, we have to convert the list of all the files to that, and we're going to extract the name of the file, so the path name. For this, we will call it name, and then we're going to click type in file.name. This is part of the Spark Utensils function, that we can extract this, and then we have the file size as well. What I essentially want to do is summarize or sum up all the sizes by file type. So this is what we need. And in order to later extract the file type, we need the file name path. And this is a for in loop. So it just goes through all the files in files. So files again is defined here with Spark Utensils with the path that we defined earlier. Then we're going to save this to a data frame. The data frame is called df files, we have to convert it. And all we have to do is type spark.create data frame and the files dictionary, which we defined earlier again, which will create that dictionary or list with all the files with the information we extracted. And then to view this, you can there are several ways to view this. We can type in df files for the data frame name and just type in show parentheses open closed, or if I want a certain format of my data, in this case I want it in pandas, so I just change it to pandas. This is a more convenient format for me, because if I type show the default and see the default data frame, the format sort of, for example, shortens the file name, and I don't see the entire name. So to view this properly, I'm using pandas. Okay, so let's paste this code into the notebook and see what happens. Okay, so back in my notebook, I'm just going to paste this information. I'm not gonna type it all out. I'm just gonna delete everything. Well, we could create a new cell, but I don't need this, or well, maybe I do. So just for reference purposes, again, as I mentioned earlier, we have to add that slash at the end so that the path is correct. So now there are two options. I can with the mouse hover below the previous code cell and add code, or I can up here on the menu go and edit and just click add code cell. So I'm going to add a code cell, and I'm going to paste this information, this code that we defined. So as I explained earlier, this here we define the path, so we can just double check that it is the correct path. Yes, it is identical. And then we use the Spark Utensils to get certain information about the paths in the files inside that path, after that path, or below that path. And then we save it to the dictionary, to a data frame, convert it, and then view the files as pandas. So let's run this and see what happens. So now it's gonna boot up Spark session, and let's see if there is an error or not. Might have forgotten to import some things before, but let's see if this works. I don't think I need anything for this. Okay, so that is perfect. We have the output here. So on the three dots here, we can see a menu for what we can do with these with this output. We have the size, and we can clear it if we want. We have a message from the Spark jobs that were successful, so we can see this job right here, and that it succeeded. Right here it says the Apache Spark session was ready, so this took 8 seconds. This is the first time I'm executing the code in this session, so it takes longer than it would normally because it's booting up the Spark session, but or starting it. But yeah, as you can see here, there's the results. So on the left, we have just a row index that's added when that we can see if we transform it to pandas, and we can see all the items in that location. And you can see the size here as well. So the size is in bytes. This is not very convenient for me. I probably want this in megabytes. I mean, we saw before that it's 99 megabytes around that for a file. So converting this to megabytes would make sense. To do this, we have to first see times divided by 1024 to get kilobytes, and then again by 1024 to get megabytes, and so on. We have to keep doing this if we have megabytes to gigabytes to terabytes to petabytes. We just have, it's just kind of a repetitive calculation, but in this case, as you can see, it is bytes. And then we have the name. So the name is good. As you can see here, it ends with .parquet. So we can, in the next stage, figure out how to separate the file name from the file type from the file name. And do note that the subfolder is also listed. So we definitely have to figure out how to skip that subfolder, because I don't need the summary for this. And as you can see, this size is also not listed, as this is not a file. All right. Okay, so let's have a look at step 3 of the notebook code. In step 3, we are going to adjust the list or the dictionary of all the files detected to skip the any file directories, or for example subfolders in that file path. We have to adjust the file size, transform it from bytes to megabytes, and finally then rename the column, because after the transition there will be after the transition we want to indicate that this file this column is now transformed to megabytes, the data inside this column. And then we convert the list to the dictionary to a data frame and then show the results. All right, so I marked yellow the things that are new. And as you can see, everything has been the same, except that here in this part, we renamed in the dictionary the file size to size megabytes, because we divide the file size by 1024 times 1024. So to go from kilobytes to megabytes, you would add additionally times 1024 here if you want gigabytes. All right, and then we have the loop. And in the end, we added an if statement to the loop that says that we do not want any file directories within that folder or files location in the Lakehouse. So if anything is a directory, for example, a subfolder, we're going to skip it. And then again, we have to convert this information, this result, to a data frame, and then we're going to view the results. So let's have a look at that. Okay, so back in Microsoft Fabric, let's add a new code cell. As I mentioned earlier, on edit, add code cell, or hover below the output plus the code cell and click new code cell. This time we will do it differently, and right here I'm just going to paste the new code. This is step 3. So in step 3 we skip any subfolders in the file path location and change the output for the file size from bytes to megabytes. Right, as I mentioned earlier, here this is the new part that we have changed. And let's run this and see if it works. So far so good. And you can see this time it was much faster, and that's because the Spark session is already running. So let's have a look at the output. We can see now that we do not, if we compare to the earlier output, we do not have the data source file summaries subfolder. That's great. And we also have a reasonable size format, which is in megabytes this time. Of course, there is a lot of accuracy here. That's fine. I don't really care about that. It's good to have. Why not? And again, as I mentioned here, the output is in a format that is quite readable. So just to show you the difference, if I use the show function, then and I play it, it will shorten the name. And you can see here now I cannot see the, I don't like the format. First of all, to me it doesn't look that great, but I do not see the full file path. And just for convenience, I keep two pandas. I'm gonna play it again, and here we have the result. So let's go to step 4. All right, so for step 4, we're doing a little bit of a jump. So what we have to do is we have to get the file. Oh, sorry, there's a typo here, but this is supposed to say file types, and save it as a new column to the data frame. Then group the file type count, group by file types. Get the file count by file type and the size by file type. And then we also want to add a timestamp column for further use further down the code path. And for example, I want to have a unique name of the CSV file we're going to save later. I want to add the timestamp as a string to the file name, the CSV file name we're going to save, but I also want the timestamp in the CSV file itself as a new column. All right, so first things that are new, we need the PySpark SQL types, because we have some statements here that we come from there. For example, here the when statement, and we also have import RE. Let me just check where this is. 1 second. This is to replace certain characters, and we don't need this at this stage, because we're not replacing yet the characters, but for the next stage we're going to need this. This is why it's here already. Sorry about that. But basically we need to replace certain characters from the timestamp output. For example, colons or anything like that, that might come with the output of the timestamp automatically, that are not accepted by Microsoft Fabric in the file name for the CSV file. All right, so we import these things, and what is new, basically here, the file format that we're extracting, you can see we have the data frame files that we saw earlier with the file names, but I now want the file type as a new column. So to do that, we add a new column, so df files.with column. This adds a new column, it's called format, and when the column name, which is here, contains a dot or a full stop, then split this element. This will create a list of all the elements that are found after this period. But to get the last one in the list, we put -1 here. So for example, if there's anything parquet, then we would get parquet because it is the last item of that list output. Then we group by this format and count the files and calculate the total size. So for this we use we define a new data frame. This is the data frame info, and this data frame is going to group the list items by format or by type. In this case I put format, but and it's going to aggregate and count by format plus sum the size for that format type. And I'm not going to show you the in-between output now, but the output in this stage will generate new column names by default. which we'll have to rename because it is a little bit confusing and it will throw an error if we use the column names that we had before. So for example, here it is going to be count1 for the column output for this group by function, and we are going to rename it to just count. And the same here, I can just add another with column renamed function, and this is going to change the name of that column, which will be sum size megabytes, and I just want total size in megabytes. All right, and then we add the timestamp column, and if you need to convert this to local time, you can do that with a further function. However, do note that if you convert this, so right now it is always UTC, which is, I think, widely accepted. But if you want to change this to your local time, you can do that with further code. However, this will create some problems. You would probably have to define this further up in the code so that there aren't any discrepancies on when it is saved to the data frame compared to what you're showing later on in the file name, for example. And then we select the columns in the desired order. I noticed before that when I didn't do this, it created an order of columns I didn't want. So the first thing I want is the timestamp of when this analysis was made. So I have the timestamp here. Then we have the format for the file type, and then we count plus the total size megabytes. So let's see what this looks like. Right, so back in Microsoft Fabric, we create a new cell, a new code cell, because we want this step by step. And I'm going to paste the code. All right, and let's execute this without much explanation, as we went through it before. I'm just gonna click run cell. I'm going to scroll down to see the result. And this was super fast, but you can see here that now we have a decent summary, and you can see we have the timestamp. The timestamp is super accurate. With Python, it is showing microseconds. Not sure why, but in this, I guess for accuracy purposes, for data science or anything like this, but we have the microseconds, and I'm not going to convert this because it is a bit tedious and tricky to do that, to have in everywhere for further use the right format. But you can see here there are definitely characters that will not be accepted in the file name if we just use this timestamp and save it to the file name further down in the code. But you can see that the group by worked. We have 2 Parquet files, 1 CSV file, and the total size of the 2 Parquet files is more or less 199 megabytes. And we have 99.5 megabytes for the CSV file. So this worked quite well. So let's have a look at the last step of our code. Right, so for the last step of this code process, step 5, we want to save the result as a CSV file in the subfolder that we created in the first step. Add the timestamp string to the file path name, and in order to have a unique identifier. All right, so okay, as you can see here, we are also now importing SQL functions, but the import RE is the one that we had earlier, and you can see here in the yellow part again what is new. The first one is we define a timestamp string, and we convert the timestamp to a string. So all we have to do is select the timestamp first row from the column to convert it to a string. We do that here with the str function, and then we replace any characters in that timestamp that are not allowed in the file's name. Now here the file name timestamp is replace, substitute any of these characters with nothing, and this is a code I found on the internet that just replaces anything that's not accepted in the file name, and do this for the file name timestamp string that we defined earlier. And then we define the file path that we're going to save. And as you can see here, we have the f function to manipulate the string dynamically with a name that we defined earlier, or a variable. And I also added the UTC indicator at the end so that we know that the timestamp of the file name is in UTC. And what I did is I just pasted the location of the data source file summaries. So to do that, we just navigate to the summaries folder, subfolder in the location. We get the ABFS path and we paste this, but I added also the name of the CSV file I want to save it as, and included this dynamic content of where we add the file name timestamp, because when we run this code in the future, it will change dynamically and automatically save it as a unique new file, and we won't have any problems to have a history of all the CSV files, and we don't need to replace anything. Right, then we save the data frame as a CSV file with header. So to do that, dfinfo write option header, we have to we add the option code to say that there is a header in the CSV file. Otherwise, it will create other headers. I think _01 _0 C _01C, something like that. And I don't want this. I want there to be the headers that we defined, and then .csv, and then we indicate the file path that we defined in the step before. And finally, we check if the file was saved successfully using the Spark utensils again. And if it exists, the file path that we defined earlier, then in the location, then we print or show in the output file saved successfully. If not, that it failed. And then we're going to view it again, just for note keeping. Okay, back in Microsoft Fabric in our notebook, let's add a new cell, a new code cell, and let's paste this code. And you can see it is a bit long. It doesn't fit on my page, but I need to scroll a bit. But that's fine, because step by step the code gets longer, of course, and there's a lot of description in this code. So let's have a look again. We adjust the timestamp to exclude the non-compatible file name string characters. We save the data frame as a CSV, define the file name with the timestamp, and this way it will be unique for each execution. Of course, because we also have microseconds in the output. So let's execute this and see what happens. I just need to, the execution is always at the top, the run cell command. So let's run this, and let's see if it works. Could be that there's something wrong, but okay, we can see the output, file saved successfully, which comes from this if statement. If the Spark utensils function finds the file path in the desired location, then it will print file saved successfully, which we have here. And we also can see that the output in the data frame to pandas is the same that we had before, which is the one that we want. Everything is fine. And just finally, to check if this file is actually saved under the file source and under the subfolder, we have to refresh the file's location. Okay, so we just click the extension dots here, we press refresh, it will refresh, and as you can see here, we have successfully saved the CSV file. It will create a folder with the CSV file inside as well, so we can view this. But you can see here the file name is what we wanted. So we have the date, and then we have the time in UTC, and then some other stuff, microseconds. And if we extend this and we click on the files folder, you can see here we have the success message, but we also have the partition for the CSV file. All right. So the final step is to test this and review it, in which case we need to extract, read the CSV file into a data frame again and print the result to see what the CSV file looks like. Okay, so finally let's review the CSV file that we created. To do this, we have to get the path of the CSV file. We do this by clicking on the folder that we created and getting the name. As you can see here, I have an error. I have CET, Central European Time. It is actually in fact a different file name with UTC, so I'm going to have to extract the new file name. And then we have the data frame. We load the information into the data frame from the CSV file. Again, we have to add the option header true because we created headers in the CSV file, so that we can view it properly and review the headers. And we have data frame to pandas to view it. And do notice that in this case, the timestamp is different in the file name than we have it in the data frame output, the format. That is because when Python saves the timestamp to the CSV file, it converts it to the ISO standard 8601 with the time zone indicator. And this could be a little bit tricky to handle later, so we would theoretically need further investigation if we want to change this. And depending on what you might want to do with the CSV file data later on, for example, such as distributing the information through a scheduled data pipeline by triggering the notebook as an action in the pipeline, and then sending the information out to stakeholders, for example, on a daily update. You might want to change the name of the CSV file when saving, and choose override if in the pipeline you always have the same location for the file name. Otherwise it could be a little bit tricky, but in my case I'm always saving an additional CSV file with a unique name to a list of CSV files, so that probably would turn out to be a little bit tricky. Okay, so back in Microsoft Fabric, let's add another code cell, the last one. And let's paste some code in here, and I will need to replace this path that I had earlier with the new path. So let me just delete this and show you how to get the path. Again, navigate to the subfolder, and in the subfolder to the folder holding the CSV file, get the ABFS file path, paste it. As you can see here, everything is correct. We have the right name plus the UTC indicator, and let's just execute this and see what it looks like. So I don't know, this is taking a while. Hopefully it will work. Okay, it worked, and as you can see, the output here is the timestamp, which is in the ISO. I forgot the number, but the ISO with the standard, with the timestamp standard, with the time indicator for the time. So it's supposed to be kind of a separator to indicate that we have the time with the microseconds, and then we have the time zone indicator at the end as well. And other than that, everything looks fine. This is exactly the way I wanted the CSV file to be saved. And I hope this is a good starting point for perhaps a solution that automates this the distribution of this information to the stakeholders. And I hope it helps you understand a little bit how to get started with a Microsoft Fabric notebook. I myself am currently a data analyst moving into a data analytics engineering role, and this is something that for the certification as well I'm learning, and I hope that it helps or motivates you to also get started with it. So one last thing. I pasted this code into AI and asked for a review to see what can be improved. Just an idea of something you can maybe do in the future as well. So definitely it mentioned that the timestamp formatting is a bit of a mess. The no error handling is there. So we definitely could add that to the code. There's no logging. The code comments are fine, but the scheduling could also be added so that it runs on regular intervals. So thank you very much for watching. I hope it helped, and hope to see you next time.